Hi, my name is Hamad Khan, and I am the Data Management Librarian here at UTA Libraries. I went ahead and put my name and email address on this slide, so if you have any questions about this presentation, you can contact me. So, as the Data Management Librarian here at UTA Libraries, I spend my time here helping faculty, researchers, and students manage their data. Good data management starts with a good plan. If you don't have a plan, you will struggle with managing your data. Today, we will cover why we manage research data. In this, I will briefly talk about the background in managing research data and why it is so important to do so. We will also cover the research data lifecycle and the steps involved. If we know the research data lifecycle steps, it makes managing data a lot easier, especially if we create a data management plan. So I will also talk about data management plans and how these documents are now being required by research and grant funding agencies to improve data management. Then I will provide an introduction on how to write a data management plan using the DMP tool. Research data is the evidence that underpins your research conclusions. It's data that has been collected, observed, generated, created, or obtained for subsequent analysis and synthesis to produce original results. As you can see in the slide, research data is collected by various devices such as audio recorders, film, SD cards, notebooks, computer programs such as Excel. Now, these devices are great for data collection and data entry, but they can be easily lost, misplaced, or even destroyed. Depending on what data collection device you have chosen, will ultimately result in the file format of your research data. Not sure if any of you have seen this article from The Atlantic that was published in 2013. The headline reads, "Most scientific research data from the 1990s is lost forever." The reason for this is because no one knows where to find it. Losing data is a waste of research funds and it limits our progress as a scientific community. There is now a push to make scientific journals require authors to upload data onto public archives as a condition for publication. We have also seen research grant funding agencies like the National Science Foundation take initiative and now require a data management plan to be submitted along with the research proposal. These initiatives help in making sure research data is accessible way into the future. Now, how do we manage research data so that we are not a part of these type of headlines? We have to first understand, why do we struggle with managing data? Well, there is so much to consider when managing data. In fact, this slide just touches upon some of the most popular topics related to data management. We must consider various formats, devices, versions, and take into consideration the protection of sensitive data. It seems like too much work, so why do we manage data? By managing research data, you will meet grant requirements, publisher requirements, ensure research integrity, enhance data security, protect your institution from reputational, financial, and legal risk. Why should you manage it? Again, you may be required by a funder or a publisher to maintain the data that underlies your published work and findings. Managing data is part of compliance with the university IRBs and your funder's data sharing and data management policies. Funders like the NIH reserve the right to audit your lab notebooks and pre-publication data. Since 2011, the NSF has required a data management plan, and the federal government is currently working to make publicly funded research data available to the public. Publications, private foundations, and specific funders like the American Heart Association may also require data management provisions. Essentially, the age of research data has dawned. If you are not actively managing it now, you should be because people are coming for it. Another reason why you should be managing data is that managing data saves you time and effort and avoids the duplication of efforts. Good research data management equals good research. You can easily find the data you need and make these available should you be asked. In addition, publishing your data can increase your citation impact and discoverability of your research and help with promotion and tenure. You don't know how someone else may use your data in the future, so it could benefit scientific progress. Managing and sharing data increases the impact and visibility of research. It promotes innovation and potential new data uses, leads to new collaborations between data users and creators. It maximizes transparency and accountability. It enables scrutiny of research findings, encourages improvement and validation of research methods, reduces cost of duplicating data collection, and provides important resources for education and training. Also, it increases the visibility of your research. We should all be working towards preserving our data, which will increase research efficiency. It will help with creating documentation that meets grant requirements, facilitate new discoveries, and with all this, you will be supporting open access. Because of all of these reasons, grant funding agencies are requiring data management plans. The data management plan was implemented by funding agencies so they can keep better track of data and know that researchers will take care of the data throughout the project and once it is completed and published. So most data management plans address the entire research data lifecycle. If you read a data management plan, it really walks you throughout the entire research data lifecycle steps. Now, there are multiple life cycles available. Now, what you see on the screen are multiple research data life cycles from different organizations, but after reviewing multiple models, they essentially share similar steps. The following data lifecycle stages are found most commonly: data planning, data discovery, data process and curation, data analysis, data preservation, data sharing, and reuse. Since funding agency requirements now require a data management plan, we have to do data planning, which is usually the first step in the research data lifecycle. But in order to successfully create a data management plan, you will need to understand the research data lifecycle. So in the next few slides, I will discuss each stage of the research data lifecycle. So usually the first stage is data planning. This is also the stage where you will complete your data management plan, which should address what kind of data will be collected, which methods will be used to collect the data, what data format and standards are appropriate, how will the data be used, how will you share the data, will your method satisfy funding requirements and policies for access, sharing, and reuse? Now, this is a lot to address, but you will be able to answer these questions if you understand the rest of the steps in the research data lifecycle. If you look at what the grant funding agencies are asking researchers to answer in the data management plan document, it really is asking how the researcher will manage the data throughout the research data lifecycle, which is why we are walking through these stages. The next stage is data discovery. Data discovery is really about what data can help you answer your research question. How are you going to capture and collect this data? Will you use surveys? Maybe the data already exists and for example, you can just use census data, which comes from open government data that is available in different repositories. Once you know what type of data you need to help you answer your research question, it is easier to answer the questions listed on this slide. What format is the raw data in? How are you recording this data? Or another way of phrasing it is, how will you do data entry? Is the data going to be transcribed into a notebook or onto an Excel sheet that is being stored on a hard drive? Where is the data coming from? What format will the raw data be in? And how is it recorded will affect the next step of the research data lifecycle. Based on the previous stage, which was data discovery, the data processing and curation stage is where the data cleaning happens, where raw data is cleaned and prepared for analysis. Again, you want to clean a copied version of raw data so that if you accidentally clean the data incorrectly, you can always revert back to the original. So let's look at data processing. Data processing includes data manipulation by a computer. It includes the conversion of raw data to machine-readable form. It involves preparing data for analysis by modifying data that is incorrect, incomplete, irrelevant, duplicated, or improperly formatted. This is also referred to as data cleaning. Once the data has been cleaned and you have data that can now be used for analysis, you go to the next step of the research data lifecycle, which is data analysis. Data analysis is the stage at which the raw materials of research are integrated to produce the insights that constitute the research findings, which will be written up and published in research outputs. Instruments and methods used for analysis should be documented. Code written for purposes of data analysis and visualization may need to be preserved and made available in support of research results. Here we include all the computational and statistical techniques for analyzing data, the algorithms and methods that underlie data mining, machine learning, undefined and statistical inference, be they to gain knowledge or insights, build classifiers and predictors, or infer causality. For sure, data analysis is at the heart of research. This is also where most researchers will analyze based on data visualizations. Statistical computing and scripting coding environments are used to analyze and produce text analysis, descriptive analysis, predictive analysis. In the past, most researchers would stop at the data analysis stage and not go any further in the research data lifecycle. While data analysis is important to research output, preserving the data for long term is valuable to the scientific community. The next step in the research data lifecycle is data preservation. Saving data on hard drives and servers is not data preservation, it is data storage. So, what is data preservation? Data preservation is a series of managed activities necessary to ensure continued access to data for as long as necessary. It is the active management and preservation of data by ensuring that research data is arranged and described with appropriate metadata, storing data in a location where it can be monitored and made available for future use and prepared for migration or transformation if the data format is damaged or in an obsolete format. Preservation ensures longevity of and continued access to your data. It may seem like an extra step, but it is a crucial part of the research data lifecycle. Preservation of your data may be something that you want to do so that you can access your data in the future, but it may also be a requirement of your funding agency. As you create a data management plan, you will probably be asked to address issues of data preservation. UTA actually provides research data preservation Through our institutional data repository, which is MAV's Dataverse. If you want to know how you can find MAV's Dataverse, this is the web address to the data repository. You can also just Google UTA MAV's Dataverse, and it's usually the first link in the search results. I put the address up here on the slide. It is dataverse.tdl.org/Dataverse/UTA. Now, the TDL in the web address stands for Texas Digital Library, which hosts our data repository. When you go to this web address, you are able to go in and view data sets that have been shared and published by UTA researchers, so you can see the type of data that we are contributing. Of course, we are still in the process of growing this data repository, so I encourage you all to submit your research data sets to our institutional data repository. You are able to submit data sets to this data repository by logging in at this web address and entering your net ID and password. If you are looking to preserve your research data for long-term use, I would suggest using UTA MAV's Dataverse. It is appropriate for data in any file type, data from any field of research, static or evolving data sets, individual files up to 4 gigabytes, data without confidential or sensitive information. The main purpose of UTA MAV's Dataverse is to provide a platform for archiving and publishing the data developed or used in support of research at UT Arlington, to promote the reproducibility of that research and to facilitate sharing and collaboration. UTA MAV's Dataverse provides many benefits. For example, version control helps track progress and keeps collaborators up to date. Published datasets are assigned a digital object identifier, also known as a DOI, to allow for citation, so you can get credit for those datasets. It allows for flexible access controls, lets users decide when, with whom, and how much data to share. Customizable metadata fields and permissions, long-term preservation of uploaded data. So here I'm returning to the final stage of the research data lifecycle, which is data sharing and reuse. Many of the steps needed to preserve data overlap with the steps needed to share data. You may be able to satisfy both data preservation and data sharing requirements at the same time with good planning. So this completes a basic introduction to the research data lifecycle. If you know each step of the research data lifecycle, then it is very easy to write up a data management plan. In fact, data planning can only be done if you are familiar with the research data lifecycle. So now let's look into data management planning. A data management plan is a written document that includes information about your research data. What data is going to be generated or acquired? How will you manage, store, and document your data? And at the end of the research project, how do you plan to preserve and or share your data for long-term accessibility? A data management plan is usually a starting point for the research project, but remember, it is a living document that may change and evolve as the course of your research changes. So this slide just shows you that data management plans are a living document and need to be updated at times depending on how your research changes. Now, why do we need a DMP? A DMP essentially documents key activities in the research data lifecycle, such as the collection, description, preservation, and access or discovery of data. Such documentation is crucial to reproducibility of research results, which is a fundamental concept of scientific investigations. By laying out the blueprint for lifecycle management of data, a DMP provides valuable details such as how the data will be preserved for long term, how and where the researcher will make the data available for sharing, and whether reuse of the data will be allowed. So, one of the reasons why we need a data management plan is for reproducibility. A DMP can help prevent or reduce the likelihood of mishaps such as data loss, data errors, and unethical uses of data. In effect, a DMP fosters improved communication and accountability for data. Data that has been generated by a federally funded project is publicly funded data. That is, data that has been made possible by taxpayer dollars. As such, unless there are restrictions or sensitivities about the data, these are data that should be made available to the public for broad sharing and accessibility. Since 2011, the National Science Foundation requires that you submit a DMP when applying for a grant. Making sure you follow the DMP requirements for your discipline when applying for NSF grants is really important, and they have different requirements by subject, which I will discuss when we start working with the DMP tool. Also, different US funding bodies and within the NSF directorates have different requirements for what elements of the data lifecycle are covered by their DMP expectations. DMPs most frequently cover the data archival and sharing stages of a project, and less frequently cover issues such as ethics, intellectual property, and data capture. A data management plan helps ensure that your data remains usable to both you, your collaborators, and other researchers beyond the end of your project. This outline of a simplified data management plan is based on the NSF recommendations for what is required in a two-page data management plan. Some sections can be standardized based on your institutional practices. Remember, when you craft your DMP as a requirement of funding, that it is an executive summary for people who do not necessarily know much about your research or the process you will use. It is meant to be a high level and a broad overview. Going into too much detail could be counterproductive, as it may make the document too long and might also make it too confusing for grant reviewers. Many research funders require that you have a plan to manage and or share your data. For example, in 2011, the NSF began requiring a data management two-page supplement with all submitted grant applications. The NIH has their own data management plan requirements. On the slide, you will see some questions that are commonly addressed in a data management plan. The NSF has laid the foundation for requiring a data management and sharing plan. It usually contains 5 sections with at least one question that should be answered per section to satisfy the requirements for that two-page data management plan document. Data management plans should include products of research, which is what types of data, experimental, computational, or text-based, metadata, samples, physical collections, models, software, curriculum materials, and other materials will be collected and or generated in the course of the project. Data formats and standards is where you address in what format and or media will the data or products be stored. Will it be on hard copy notebook, or will it be in the format like, for example, a JPEG? Dissemination, access, and sharing of data really is about what specific dissemination approaches will be used to make data available and accessible to others, including any pertinent metadata needed to interpret the data. In this case, available and accessible refers to data that can be found and obtained without a personal request to the PI, for example, by download from a public repository. What plans, if any, are in place for providing access to data, including websites maintained by the research group and contributions to public databases and repositories. Reuse, redistribution, and production of derivatives? What are your policies regarding the use of data provided via general access or sharing, practices for appropriate protection of privacy, confidentiality, security, intellectual property, and other rights should be communicated in this section. The rights and obligations of those who access, use, and share your data with others should also be clearly articulated. Archiving of data. When and how will data be archived, and how will access be preserved over time? For example, will hard copy logs, instrument outputs, and physical samples be stored in a location where there are safeguards against fire or water damage? Is there a plan to transfer digitized information to new storage media or devices as technological standards or practices change? Now, this data management plan document is not only helpful to research funders, but it is great for you, the researcher, as well, as you can go back and see what your plan was and if you are meeting the requirements you set out to meet. Now, the data management plan documentation is a part of data management, and we should follow the templates given by funding agencies to meet their requirements. Overall, data management plans address the research data lifecycle. So, how do we create a data management plan? It's important to have some sort of plan when it comes to managing data. If executed correctly, you will be able to make sure your data is safe and secure for the future. So, for this, we use data management planning tools. The most popular tool is the DMP tool. This tool is free and open for anyone to use. This tool helps us keep in mind all of the issues we must address related to our research data. So the easiest way to create a data management plan is using the DMP tool. You can access the DMP tool by visiting DMPTool.org. You can open up a web browser and go to DMPTool.org. And once you're on DMPTool.org, you'll see this website, right? And on the right-hand side here, there's a sign in button. And University of Texas at Arlington is affiliated with the DMP tool. Many research institutions are affiliated, other universities also. So again, when you go to this page, on the right-hand side, there's a sign in button. And then if you hover down, go to option 1. It says if your institution is affiliated with the DMP tool, click your institution, because University of Texas in Arlington is affiliated with the DMP tool, and this is the easiest way to sign in. So once you click that, it says look up your institution here. And what you're going to do is you're going to type in University of Texas, and you get options here. The top option says University of Texas at Arlington. There's University of Texas at Austin, Dallas. But since we're at Arlington, we're going to click on UTA. And then you just click on the Go button. And now it prompts you to enter in your net ID. And so I'm just going to enter my net ID and my password. And I'm just going to hit submit. And here I log into the DMP tool. And what you first see is your dashboard. And here you can see NSF templates that I use to create a data management plan. By the way, these aren't actual official data management plans I've created. These are actually for instruction that I do in other workshops. But I just want to show you how easy it is to access the data management plan tool. I know a lot of people get nervous that, oh, will I have to register my name, my email address, my birthday, all those other fields to sign up for it. You don't have to do any of that. You saw how simple it was to log into the DMP tool. So once you log in, if you have never used the tool,
obviously your dashboard is going to be empty. But if you have used this tool, you will see all of your data management plans from the past listed down here. And it is so easy to create a data management plan. You can go here, click create plan, or you can click down here. So if you click on create data management plan, basically it gives you the fields to enter right here on you can type in what type of research project you're planning and just kind of like go through this, right? But what I really also want to highlight, like this walks you through each of the steps for your funder. And you can even find your funder down here and they will open up the template for that funder, what they require in their data management plan. I just wanted to show you, you can play around in here. So one other really useful thing I find is if you go to learn right here in the top right hand side, it has a quick start guide, who can use this tool, how to log in. It gives you this kind of basic information. How do I create a data management plan? It kind of just gives you the steps on how you can do it. So this learn feature on the right hand side is really valuable. Here is some, again, under learn is data management general guidance. Click this. It has the types of data file formats, and it just explains who requires a plan and why it's required and gives you some background information. The other useful thing besides this create a plan button is that if you go public, actually let's do this, funder requirements. If you go under learn, go to funder requirements, and here it lists out templates for data management plans. So you can see the template and the name. And here in this column, you can see the funder, right? And the last time this template was updated. So for example, I know NIH has been updating what they require in their data management plan. So if you do not see a plan here, by the way, it has a lot of pages, so you have to click down here and you can scroll through this to find the funder requirements for the data management plan. But this search bar is really great because you can type in NIH and hit search, and it has the template for the different NIH grants. And if you notice, they're actually updating what is required in their data management plan. So this is forthcoming in 2023, as you can see here, and it was last updated this year actually. So they try to keep up to date on the templates so you know what to include in your data management plan based on the funding agency that you will be applying for. Okay, so again, when you have time, definitely come in here, go under learn, look at the funder requirements or search for the funder, create a plan. The other thing I want to show you is that you can actually, like if I go back to my dashboard, you can see the visibility. You can keep your data management plans private so no one can view it. Only you can view it. And you can see some of mine are public, some are private. The other thing is you can easily download a copy of your data management plan and attach it to like an email or send it to a funder or upload it to a funder. So for example, if you go to download, there are multiple formats that you can download your data management plan in, the most popular being Word or PDF. Again, you can keep it private or you can make your data management plan public so anybody who is using the DMP tool can view your data management plan. And so if you want to see other people who have made their data management plans public, go back up to the Learn button right here and go to Public Plans. Right under Funder Requirements, there is Public Plans. And it just is organized with the last project that was made public. And on the right-hand side, you can open up this data management plan and view it in a PDF. So you can see the project title, the template that they're using, and the organization that this person belongs to. So this is valuable, but I want to make one thing also highlight. Public DMPs are plans created using the DMP Tool service and shared publicly by their owners. They are not vetted for quality completeness or adherence to funder guidelines. So this is important that you should not use these as examples, right? But I will still say this, that you can actually learn from different public DMPs. Some of these are great and some of these are not so great. But again, they are not vetted for quality, completeness, or adherence to funder guidelines. So if you notice here, this is the title of the project. This is the NSF grant that template that they use. And this person is from University of Arizona, and they made their data management plan public. So I just opened it up, and these are the creators. Again, you can view what some people are doing for their data management plans and just kind of get some information, types of data that they're planning on getting funding for, their data metadata. This is just good for viewing, but again, follow the template and know the research data lifecycle stages. Again, these aren't vetted for completeness, or who knows if this was even funded. Obviously, you can check into it, but it's just a good resource for you guys to see. Again, I would suggest that you go in here at a later time and create a plan. Go into create a plan, and you don't have to make it public. In fact, you can just make a fake plan just to test it out, and you can delete it because it's very easy. If you go back to your dashboard, go under actions and hit remove, and it's gone. This is a very easy tool to use. It walks you through it. When you hit create a plan, just fill out the fields. So I just wanted to introduce you to the data management plan tool and show you that it is not difficult to use, and it's very easy to sign into.
Thank you all for watching this presentation. If you have any questions, please feel free to reach out to me at my email address. And if you have any questions that are data related, you can reach out to datacave@uta.edu. Thank you.